Okay, boys. What I'll do is I'll post the solutions, those of you that have no problems with it and just want to correct the answers. But this is obviously a video of me doing the solutions, okay, if any of you are still finding it a little bit tricky. Okay, so your homework that I gave you for the weekend, boys, let's have a look at it here. Okay, so this is question 2A. Alright, it says a complex number z1 is equal to a plus bi, where I squared is equal to minus 1. As shown in the Aragon diagram below, write the value of a and the value of b. Okay, I'm going to draw out this Aragon diagram because I'm going to need it, okay, for the other parts of the question. Okay, so it goes out as far as minus 2 this way on the real axis. It goes out 2, 3, 4, 5 on the positive real axis. So 1, 2, 3, 4, and 5. Goes up as far as 5 on the imaginary. Might as well label these. Okay, and down as far as minus 2. Okay, excellent. And they had Z1. Okay, typical now. I'll just get rid of that there. That's because that'd be in the way. So 1, 2, 3, 4, and 5. Okay, sorry about that. Okay, and Z1 is plotted here. Okay, so that's Z1. It's labeled. Okay, so the first part of the question was write down the values of A and the values of B. Okay, for the complex number Z1. Okay, so A and B. So A, obviously your real part, which is 3, and B, which is your imaginary part, which is minus 1. So if you're to put that in the complex form, it would be 3 minus I. Okay, that's what it would look like. Okay, now part 2. Okay, that was A part 1. Okay, so part 2. So part 2 says Z2 is equal to, okay, minus 1 plus 2i. So Z2 is equal to minus 1 plus 2i. Alright? This is plot Z2 on the Aragon diagram. So again, I'll go and get the red here. Minus 1 on the real axis, okay, and then plus 2 on the imaginary axis. Okay, so there is Z2. Alright? Now, and the next thing it says, okay, is part 3. And part 3 is saying that Z3 is equal to Z1 divided by Z2. Okay, and write Z3 then in the form x plus yi. Alright? Now, let's write Z3 in the form of the complex. So Z1, as we know, okay, I've written it out above there, just up here, okay, is 3 minus I, okay, and divided by Z2, which is minus 1 plus 2I. Now, any of you that saw my clip that I did with you last week, okay, you'll see that you cannot have a complex number in a fraction form. So the way out of this is you multiply, okay, above and below the line by the conjugate of the denominator. So minus 1, change the middle sign to minus 2i, divided by minus 1 minus 2i. Okay, so as you can see, lads, you're changing that sign. So this is the denominator. You want the conjugate of this number, so you change this sign to a minus and a minus. Alright, so now we can multiply this out. Okay, and tidy it up. Alright, so 3 by minus 1 is minus 3. And 3 by minus 2 is minus 6i. Minus I by minus 1 is plus I. Minus I by minus 2, okay, is plus 2i squared. Move on to the bottom. Minus 1 by minus 1 is 1. Minus 1 by minus 2 is plus 2i. Plus 2i by minus I, or excuse me, plus 2i by minus 1 is minus 2i. And plus 2i by minus 2i is a minus 4i squared. Okay, let's tidy these up. Remember, this is Z3 we're looking for. Okay, so we've got minus 3. Minus 6i plus I is minus 5i. Plus 2 times, remember I squared is minus 1. Okay, they cancel. 1 minus 4 times minus 1. Okay, let's finish this off here now, lads, in one line. So over here, lads, okay, 2 times minus 1 is going to be minus 2. So minus 2 minus 3 is minus 5. Minus 5i. Over. Minus 4 by minus 1 is a positive 4, so 1 plus 4 is 5. Lucky enough that 5 goes into everything above the line. 5 goes into minus 5 minus 1 times, and 5 goes into minus 5 minus 1 times. Okay, and you get Z3 to be simply 1 minus I. Okay, and that's it there. It's or that's Z3 there now done. Okay, so it's 1 minus 1. Excuse me. Minus 1 minus I. Alright. Now, B. Okay. I'll move on to a new page here for you. Okay, so what's B saying? It's saying solve for Z. We've got 2 Z minus 6, okay, times 4 minus 6I is equal to minus 1 plus I, okay, times 4 minus 2I. Alright, and we want to solve for Z. So what I'll do is, I can multiply out all these brackets, okay, bring all my real and imaginary numbers to the right hand side of the equation, leaving Z to the left hand side of the equation, since that's what I'm trying to solve for. Alright, so let's multiply out this side first. So I'm going to have 2Z is equal to minus 24. Sorry lads, my apologies. Okay, it's minus 24, okay, plus 36i. Okay, now it'll be multiply this out. Okay, so we've got minus 1 times 4, which is minus 4. Minus 1 times minus 2i is plus 2i. I times 4 is plus 4i. And I times minus 2i is minus 2i squared. Okay. Now what I'll do is I'll move that across and move that across. So I'm going to have 2z is equal to minus 4 plus 2i plus 4i minus 2. Now instead of I squared, I'm just going to replace that with that minus 1, because we know I squared is equal to minus 1. Okay, plus 24 is that minus 24 is coming across, and minus 36i is that plus 36i is coming across. Okay, let's put our real numbers with real numbers, imaginary numbers with imaginary numbers. So, okay, minus 4 is real, this will become real, and this is real. Alright, so we've got minus 4 plus 24 is obviously 20. Okay, minus 2 times minus 1 is a plus 2, so it's going to be 22. Okay, 2i plus 4i is 6i. Minus 36i is going to be minus 30i. Now, I don't want that 2 there, so I'm going to divide everything by 2. Okay, and we get z is equal to 11 minus 15i. Okay, and there's z. Alright, let's move on to the next question I gave you. Alright, move on to a new page again. So this was question 20, this was 2016. Okay, and this is part A. Okay, it says it's at the start of the question, it says z1 is 1 plus 3i, z2 is 2 minus I, and again, as it always says, I squared is equal to minus 1. Now, says let Z3, well I'll write out Z1 here, make it easier for me and for you guys to see it. And Z2 is 2 minus I. Okay, and it's saying that Z3 is equal to Z1 plus 2 times Z2. Okay, we want to find Z3 and write it in the complex form. Okay, so Z3 is equal to Z1, which is 1, plus 3I, plus 2 times 2 minus I. That's 1 plus 3I, plus 4 minus 2I. That's 5 minus I. So there's your Z3. Okay, now it says plot Z1, Z2, and Z3 on the given Argand diagram. So I'll just do a quick sketch of it here. Okay, so I'll do it over here. We have space to do it. Okay. Okay, so Z1 is 1 plus 3I, so it's 1 and 3I is here. Remember, this is your imaginary, this is your real. Okay, and it's 2 minus I, which is down here, so I should label these. So that's Z1, that's Z2, and 5 minus I is down here. Okay, and there you have it, Z3. Alright, now apologies, lads. I'm just looking back over my work there. I can see that 3I minus 2I should be obviously a plus I. Okay, so that there, okay, changes, and it is in fact 5 plus I, so it's up here. My apologies, boys. Okay, now, that's better. Alright. So moving on then to the next part of the question, which is part C. It says investigate, okay, if the mod of Z2 minus Z1, Z3, okay, is equal to the mod of Z1 plus Z2. Okay, so a small bit of work needs to be carried out here first of all, lads. Alright. So we need to get what Z2 minus Z3 is first of all. So it's the mod. We have Z2, which is 2 minus I, minus Z3, which is 5 plus I. Okay? And the mod then of 1 plus 3I, plus Z2, which is plus 2 minus I. Okay? So here's going to be 2 minus I minus 5 minus I is equal to 3 plus 2I. Alright? No, we did that all together there, lads. Okay? So this will be 2 minus 5 is minus 3, minus I is minus 2I. Okay, so we want to get the mod of this. So therefore it's the square root of your real to be squared plus your imaginary to be squared equal to your real to be squared plus your imaginary to be squared. Minus 3 to be squared is 9, minus 2 to be squared is 4, so it's square root of 13. 3 to be squared is 9, 2 to be squared is 14, yes. Okay, we've investigated, lads. We can safely say, alright, that they are equal to each other. Okay, and on to D then. Alright, I can put D in over here for E. Okay, it says find the complex number W such that W is Z1 divided by Z2. So it's very similar. So it's W is equal to Z1 divided by Z2. Okay, so we've done this just on the previous question, lads. So we have to multiply above and below the line by the conjugate of the denominator. Okay, so what was Z1 again? Z1 is 1 plus 3i. Okay, and Z2 is 2 minus I. Okay, so we must multiply above and below the line by the conjugate of the denominator, which is 2 minus I. So the conjugate of that would be 2 plus I. Because we're just changing the sign of the imaginary number. And then we just multiply out the brackets. Okay. So 1 times 2 is 2. 1 times I is I. Okay. 3I by 2, 6I. And 3I by I is plus 3I squared. Bottom line, 2 by 2 is 4. 2 by I is plus 2I. Okay, then minus I by 2 is minus 2I. Minus I by plus I is minus I squared. Alright, tidy up the top line. We get 2 plus 7I plus 3 times minus 1, as we know I squared is minus 1. They cancel, so we go 4 minus minus 1. So W will be equal to, well, 3 times minus 1 is minus 3, so 2 minus 3 is minus 1, plus 7, I, all over 5. Okay, they want in that format A plus BI, okay, so you just simply write minus 1 over 5, okay, plus 7 over 5. Okay, lads, and that's that question complete. Alright, so what I'll do is I'll give you another question on complex numbers for homework.